Let's see how we can use truth tables to test for joint satisfiability, tautological equivalence, and tautological entailment. Okay, how can we use truth tables to test for joint satisfiability? Let's look at an example. Here we have a joint truth table for 3 sentences. The first sentence is A, if and only if B or C. The second sentence is if C, then not A. And the third sentence is if A, then not B. And we want to find out whether there is a valuation on which all 3 sentences are true. Now, to figure this out, we need to fill in the columns under these 3 sentences here. I'm going to start with the first sentence, A, if and only if B or C, and I'm going to start with the innermost connective. That is, in this case, the disjunction sign. Now, B or C is true when both B and C are true. It's true when B is true and C is false. It's true when B is false and C is true. It's false when both B and C are false. And then to fill in the rest, T, 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 F. Okay, so that's the valuation under the disjunction sign. And now to fill in the column under the biconditional, I need to look at the truth value of A, and I need to look at the truth value of this disjunction here. And the biconditional is true if and only if both sides flanking the biconditional have the same truth value. So that's T, 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 and T. Now T, F, 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 T, F, F, T, F, F, T, F, and F, F, T. Okay, so I've filled in the column under our first sentence. Next, let's look at our second sentence. If C, then not A. I'm again going to start with the innermost connective, and that is the disjunction sign, and fill in the column there. F, 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 T, 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 T. And now to assess the truth value of the conditional, I need to look at the truth value of C and the truth value of the consequent here. Now, when the antecedent is true and the consequent is false, the conditional is false. When the antecedent is false, the conditional is true. When the antecedent is true and the consequent is false, the conditional is false. When the antecedent is false, the conditional is true. Now, when both antecedent and consequent are true, the conditional is true. Same thing here. And then when the consequent is true, but the antecedent is false, the conditional is true. Okay, so here I filled in the column under our second sentence. And it only remains to be seen on what valuations the third sentence is true. So I'll start by filling in the column under the negation sign. That's F, F, T, T, F, F, T, T. And now I need to fill in the column under the conditional. Now I know that the conditional is false if and only if the antecedent, which is A, is true and the consequent is false. So that means the conditional is false, false, true, 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 and true. So that was the first big step in our task here. We have completed the truth table for our 3 sentences. And next, we need to look at this truth table to figure out whether the 3 sentences are jointly satisfiable. And in order to determine that, we need to look at the columns under the main connective for each of the 3 sentences. So we are going to look at this column here, and at this column here, and at this column here. And what we want to find out is whether in any one of these columns there is a row, whether there is a row in which each one of these three columns has the same truth value. So let's see, TFF, nope. TTF, no. TFT, no. FTT, no. FTT, FTT, FTT. But now, when we look at our final column at the bottom here, I see that sentence 1 is true, and sentence 2 is true, and sentence 3 is true as well. So that means that there is a valuation on which all three sentences are true. Specifically, it is the valuation where A, B, and C all are false. And since there is a valuation that makes each one of these three sentences true, that means that these three sentences are jointly satisfiable. And that's how you can use truth table to test for joint satisfiability. Let's see how we can use truth tables to figure out whether given sentences are tautologically equivalent. In this example here, I'm looking at two sentences. The first sentence is the conditional if A, then B, and the second sentence is the conditional if not B, then not A. We see that we have two atomic sentences, A and B, so our truth table is going to have 4 rows, one for each of the possible valuations of A and B. Now the conditional if A then B is false if and only if A is true and B is false. So it's false in the second row of our truth table here. In all other cases, this conditional is going to be true. So we have evaluated our first sentence. Now our second conditional, if not B then not A, is false just in case not B is true and not A is false. So let's see when that happens. Now the negation sign just flips the truth value of B. So that's going to be F, T, F, T. And the negation sign before A flips the truth value of A. So that's going to be F, F, T, T. Now, in order to figure out the truth value of this conditional, we need to look at these two columns. In the first row, the conditional is true because the antecedent is false. In the second row, it is false because the antecedent is true and the consequent is false. In the third row, it's true because the antecedent is false. And in the final row, it's true because both antecedent and consequent are true. And when we now look at the two columns under the main connectives of our two sentences, we can see that these two sentences indeed are tautologically equivalent. And the reason is because they exhibit the same pattern of T and Fs in the column under the main connective. In both cases, it is TF, TT. And so the two sentences are tautologically equivalent. Let's see how we can use truth tables to figure out whether given premises entail a certain conclusion. We said that given premises entail a conclusion if and only if every evaluation that makes all premises true also makes the conclusion true. So we need to construct the joint truth table in order to figure out whether this is in fact the case. Now in this particular example, I am looking at an argument with two premises. The first premise is a conditional. If B and A, then C. The second premise also is a conditional. If C and A, then B. And the conclusion likewise is a conditional. If C and B, then A. I'm going to mark the conclusion here with an exclamation mark, just to remind ourselves that this is the conclusion. Okay, let's just fill in this truth table in the assessment column to see whether these two premises entail the conclusion. Let's first look at the antecedent of our first conditional, B and A. That's true in the first row, true, false, 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 and false. Now, in order to figure out the truth value of this conditional, we have to look at both the antecedent and the consequent. Now, in the first row, it's true, false, true, 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 and true. Why is that? Well, in all of these cases, the conditional is true because the antecedent is false, and a conditional with a false antecedent is true. And only in the second row, the conditional is false because the antecedent is true, but the consequent C is false. Okay, so that's the assessment column for our first premise. Our second premise also is a conditional, so let's first assess the antecedent. The antecedent is a conjunction, so we have to look at the truth values of C and of A to figure out the truth value of this conjunction. That is going to be T, F, T, F, 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 and F. So the conjunction is only true in the first row and in the third row. In all other rows, the conjunction is false. Now, to figure out the truth value of our conditional, we need to look at the truth value of the antecedent, which is our conjunction here, and of the consequent, which is B. In the first row, it's true because both are true. In the second row, it's true because the antecedent is true. In the third row, it's false because the antecedent is true and the consequent is false. And then in all other rows, it's going to be true because the antecedent is false. Okay, that was the assessment column for our second premise. Finally, let's look at the assessment column of our conclusion. If C and B, then A. To evaluate the antecedent, we have to look at the truth values of B and C. That is true, false, false, true, and then false all the way down. True, false, false, true, false, 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 and false. And then to determine the truth value of our conclusion, we need to look at the column under the main connective of the antecedent and at the column under our atomic sentence A. And we see that this conditional is true, 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 false, true, 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 true. All right, big step accomplished. We have constructed the joint truth table for our two premises and the conclusion. Next, we need to figure out whether every valuation that makes both premises true is also a valuation that makes the conclusion true. So what are the valuations that make both premises true? Well, we have to look at the columns under the main connectives. That is this column here, and also this column here. Now, do these two columns contain, are there rows in which these two columns both contain the truth value, exhibit the truth value true? I would say yes. That is, in the first row, both the first premise and the second premise are true. In the fourth row, both are true. And then actually all the way down, right? So it's really only in the second and in the third row where one of them is false. So what that means is that our premises entail the conclusion if and only if our conclusion likewise is true in the first and in the 4th to 8th row. Now, is that indeed the case? Well, we have to look at this column here. Now we see it has TTT, but there is an F here, and then T all the way down. Okay, so it looks like we have found out that our premises do not entail the conclusion, because there is a valuation on which both premises are true, but the conclusion is false. And so the premises do not entail the conclusion. That's our first result here. Let's just double check our work to make sure we haven't made a mistake. So in the 4th row that we are looking at now, A is false and B and C are true. Now when A is false, the antecedent of this conditional is false, so the whole conditional is true. So we did come to the right conclusion here. Now when A is false, again, the antecedent of this conditional is false, and so the whole conditional is true. So we did come to the right conclusion here. And then finally, when C and B both are true, the antecedent here is true. But if A is false, that means that this conditional is false. And so we also have come to the right conclusion here. So double checking our work confirms the result that we achieved. This argument is not tautologically valid. The premises do not entail the conclusion.